everyone, it is Mr. Ranieri here. This is a revision video to show how to solve equations with a repeated variable. By that I mean I've got an x on this side, but I have another x term on this side. So I've got a three-step process here. Step 1, step 2, step 3. Let's work through and see how it works. Okay, first of all, I have an equation here. 5 times x add 30 equals 15. And I want to figure out what number x is. Well, I look at it and I see that I have terms. The terms are separated by the plus and minus signs and the equal signs. So I have 3 terms here. A 5x term, a positive 30 term, and a 15 term. Notice that the term includes the plus or minus sign that comes before it. So this 30 term is positive 30. My rule here is first to expand any brackets. None of these questions have brackets, so we don't have to worry about that. And then to collect like terms and do the other stuff. Here, if you look on the left-hand side, I've got an x term and a constant term. Are these like terms or unlike terms? These are unlike terms. So I can't collect like terms because I have none. So that is done. Step 2, move the unknown to the left-hand side of the equation. Like I said, I've got 3 terms here. Some of these terms are unknown terms, the terms with a letter in them, and the other ones are constant terms, the terms that are just a number. Looking at these 3 terms here, which is an unknown term? The only unknown term is 5x, and that is already on the left-hand side of the equation. When I say left-hand side, I mean to the left of the equal sign. So that I have done. Finally, use inverse operations to isolate the unknown, get the unknown by itself, to get x by itself, and solve the equation. So by that, I mean, I'm going to start by using this strategy up here, which is to get all my terms with a letter in them to the left-hand side and all of the other terms to the right-hand side. This term, the 5x, has a letter in it. It is already on the left-hand side. Good. This term is a number term, a constant term. So that needs to go to the right. So it needs to move. And this term is also a number term, needs to be on the right, and it is already on the right. So there's only one term that I need to move, which is this one here, because it's a number term, and I want my number terms to be on the right-hand side, my constant terms to be on the right-hand side. So the 5x is going to stay here. The equal sign is going to stay here. The 15 I will copy down, but the plus 30 will move to the other side, and it becomes the opposite. So you can move terms from the left-hand side to the right-hand side and back, but when you move a term from one side to the other across the equal sign, it goes from positive to negative. It becomes the opposite, the inverse. Do you notice that I copy down everything else? That is important. The 5x I copy down, the equal sign I copy down, the 15 I copy down. The only thing I'm changing is that positive 30 term moves to the other side and becomes the opposite, becomes a negative 30. All right, well, now I'm only going to focus just on this bit. Everything else, like I said before, I'm just going to copy down. The reason I'm focusing on this is because you can figure that out. You can put that in your calculator and get an answer. What number do you get when you put that in your calculator or figure it out in your head? You get negative 15. So I'll copy down my therefore sign, copy down the 5x, copy down the equal sign, and replace this with negative 15. Now I'm getting closer, right? One step at a time, I'm getting closer. Now I only have my letter terms to the left, and I've only got one letter term, which is 5x. So now I can break apart this letter term, this unknown term. To break it apart, I notice that this is 5 times x. There's an invisible time sign between here. So this really means 5 times something is negative 15. What is the opposite of multiplying by 5? The opposite of multiplying by 5 is dividing by 5. So this multiply by 5 will go to the other side and become a divide by 5. It was a multiply by 5, now it is a divide by 5. You'll note that I like to write my divide by 5 as a fraction. You can do it using the divide symbol if, oopsie, that's not a divide symbol. You can do it using the divide symbol if you prefer. So this is the same as this. So this is the same as this. Okay, now I've got x by itself, right? So I'm pretty much done. The only thing that is remaining for me to do is to get this here, this negative 15 divided by 5. 15 divided by 5 is 3, and then I have the negative sign out the front, so x is negative 3. Another way to think of it, just for completeness, is if we had negative 15 divided by 5, which would be the same as this. These are two different ways of writing the same thing. I've got a negative divide positive is a negative. 15 divide 5 is 3. So you can do it in two separate parts. All right, let's try another one. Let's go back and look at how many terms we have. Expand any brackets. I don't have any brackets. I don't need to do that. Let's move all of our letter terms to the left and number terms to the right. I've got, there's a term, there's a term, there's a term, and there's a term. 4 terms, x, positive 3, 2x, and negative 1. Which of these terms are letter terms and need to be on the left-hand side? This term, the x term, and the 2x term over here. So I'm going to have to move this 2x term over to the other side. All right. Which of these terms are number terms and need to be on the right-hand side? The positive 3 term and the negative 1 term. The negative 1 term is already on the right-hand side, but this positive 3 term is a number term, so I want to move it to the right-hand side. So what will we have? The x will be on the left. The x will be on the left. There we go. I might just ignore this bit for now, just so we can do it one step. Don't worry about that. The x is still there. The plus 3 has moved to the other side. So when I move it to the other side, it turns from positive 3 into negative 3. The 2x was on the right-hand side, but moved to the left-hand side. If I move this positive 2x term from the right-hand side to the left-hand side, it was positive. Now it will become negative. The negative 1 term will stay there. So I've got my 4 terms here. Oops. I've got my 4 terms here. Some of them have stayed where they are, the x term and the negative 1 term, but others have moved. And when they moved, they changed from positive to negative, or negative to positive. Okay. Now that I've moved my terms to the correct side, I can start to collect like terms. If you look on the left-hand side, I've got x take 2x. You can think of this as one lot of x. One lot of x, take 2 lots of x. If I have 1 take 2, the answer is negative 1. So I've got negative 1 times x, which you can also write as negative x, equals, on this side I've got negative 1 take 3 minus 1 take 3 is negative 4. So negative x is negative 4. If I multiply both of these things by negative 1, I've got x equals 4. So there's a little trick for you that if you know what negative x is, then you can negate both sides. You can multiply both sides by minus 1. This times negative 1 will turn positive, and this side, it was negative. If I times it by minus 1, it will become positive. This process of multiplying by minus 1 just flips something from negative to positive or vice versa. Finally, I have this equation here. There's a 2x term, a plus 4, an x, and a plus 2. I can look at these terms. There we go. I can look at these terms. Out of these terms, which terms are in the wrong place? I've got a letter term here. That's in the right place, it's on the left. I've got a number term here, but I want that to be on the right. I've got a letter term here, that should be on the left. And I've got a number term here that is in the right place. So the 2x will stay where it is. I'm just going to, again, skip this step. The 2x will stay where it is. The plus 4 will move to the other side where it becomes negative 4. The x will move from this side to the left-hand side where it was positive x, so now it would be negative x. And the 2 is staying where it is. Now I can simplify this. 2 lots of x take 1 lot of x. Remember, if there's no number before it, you can treat it as 1 lot of x. 2 lots of x take 1 lot of x is 1 lot of x. 2 take 4 is negative 2. So my answer is 1x equals negative 2. We can simplify 1 lot of x even further. 1 times x is the same as x. So therefore x equals negative 2. This has been a revision. You might still have questions. Please ask me, I'll help you out. This is Mr. Ranieri, and good luck. Ask questions, give it a go, check your answers. See you next time. Bye everyone.